First, we start from question number 8. For the first Roman, discuss the development of atomic models from Thomson's atomic model and the Bohr atomic model, specifically commenting on the assumption and failures. Second Roman, explain the experiment that promotes the discovery of electron. So for the answer for the first Roman, we have three models: Thomson plum pudding model, Rutherford planetary model, Bohr hydrogen model. So the description for the models: first, for the Thomson, positive charge spread uniformly throughout the sphere of atoms size with electron embedded in the background. For Rutherford, nucleus is the central charge core with positively charged surrounded by moving negative electrons. For Bohr hydrogen model, predict the frequencies and wavelength of all possible transition in atomic hydrogen. Next, for the assumptions, for Thomson's, first, arrangement of charge is in a stable equilibrium. Second, electrons do not move around rapidly due to the electric force equal to 0. 3. Vibration of electron produce electromagnetic radiation. Next, for Rutherford planetary model, first, the scatterer is so massive, alpha particles initial kinetic energy equal to final kinetic energy. Second, target is so thin, only one scattering occur. Third, bombarding particle and target scattered are so small. And last one, only Coulomb force is effective. Next, for Bohr hydrogen model, first, orbiting electrons do not continuously radiate electromagnetic energy because stationary state exists in atom. Second, emission or absorption of EM radiation only occur in transition between stationary states. Third, law of physics only apply in stationary state. And last one, electrons orbital angular momentum is equal to h over 2 pi. Next, we go to the failures for all the model. First, for Thomson, first, unable to calculate light spectrum of hydrogen. Second, impossible to directly see internal structure of atom. Rutherford planetary model, first, electron accelerate due to circular motion. Second, it continuously radiated energy and makes total energy decrease. Third, electron orbit becomes smaller till crash the nucleus. For Bohr hydrogen model, successfully apply only to single electron atom, unable to calculate the intensity of the spectral lines. Third, can't explain binding of atoms into molecule. So next, we go to the answer number 2 Roman. Experiment that promotes the discovery of electron is J.J. Thomson's cathode ray experiment. He proved that cathode ray were negatively charged particle electrons by deflecting them in electric and magnetic fields. The key of it is to evacuate the glass tube. He measured the ratio of electrons charged to mass by sending electrons through a region containing a magnetic field perpendicular to an electric field. When magnetic field is off, electrons enter the region and accelerated upward by electric field. The ratio Q over M can be determined if velocity is known. When magnetic field is on, there is no deflection of electrons occur, so velocity can be determined. He noted that Q over M ratio was independent of discharge, gas and cathode metal. Then he concluded that these particle electrons must be a universal constituent of all matter. So next, for question number 9. Based on the Millikan's oil drop experiment, a charged oil drop falls 5.0 mm in 20 seconds at terminal speed in the absence of an electric field. The relative density of air is 1.35 times 10 power of negative 3 kilometer meter negative 3, and that of oil is 0.75 times 10 power of 3 kilogram meter negative 3. The viscosity of the air is 1.80 times 10 power of negative 5 Newton second meter negative 2. For the first Roman, how many force that exert on the oil drop in the absence of an electric field? Second Roman, find the radius of the oil drop. Given distance fallen 5 millimeter, time taken 20 second, terminal velocity S over T equal to 2.5 times 10 power of negative 4 meter per second. Density of oil 0.75 times 10 power of 3 kilogram per meter cube. Density of air 1.35 times 10 power of negative 3 kilogram per meter cube. Viscosity of air 1.80 times 10 power of negative 5 Newton second per meter square. Acceleration due to the gravity G equal to 9.81 meter per second squared. So for the first question, first Roman, how many force act on the oil drop? First, weight of the oil droplet downward, buoyant force upward, and third, viscous drag upward. So we go to the second Roman question, find the radius of the oil drop. First, weight minus buoyant force equal to viscous drag. So mg minus v for air g equal to 6 pi eta r vt. So let mass equal to density for oil times v equal to density of oil bracket 4 over 3 pi r cube. Then let volume equal to v equal to 4 over 3 pi r cube. Now plug into the first equation. Density of oil times 4 over 3 pi r cube times g minus density of air 4 per 3 pi r cube times g equal to 6 pi eta r vt. Next, 4 over 3 pi r cube g in bracket density of oil minus density of air bracket equal to 6 pi eta r vt, and we cancel out the pi for each in there, cancel out pi, then it becomes 4 over 3 r squared g in bracket density for oil minus density of air equal to 6 pi 6 eta vt. Next, we r squared equal to 6 eta vt over 4 over 3g in bracket density of oil minus density of air. And then we substitute the eta value and substitute Vt value, the G, and the density of oil and air, and we got 2.75 times 10 power of negative 19, and then we square root the answer, and we get 5.24 micrometer for its radius.
A Rutherford scattering experiment is set up with alpha particles incident on a silver foil, and the scattered alpha particles are observed by a detector at the scattering angle. How does the counting rate number of counts per second in the detector change in each of the following cases? State your answer whether 1 increases, 2 decreases, or 3 remain the same. For 1, the detector moves to larger angles. The second one, the alpha particles are replaced with protons. And the last one, the silver foil Z is equal to 47 is replaced with gold, Z is equal to 79. For the case 1, moving detector to a larger angle. So first, what happens if we move the detector to a larger angle? As the angle increases, the denominator gets bigger, so the scattering rate decreases. On the case 2, replace alpha particle with protons. Next, what if we replace alpha particles with protons? Alpha particles have a charge of positive 2 and protons only positive 1. Since the scattering rate depends on the square of the charge, it drops significantly. So it will be decreases. On the case 3, replace silver foil with gold foil. Finally, what happens if we change the foil from silver to gold? Gold has a higher atomic number and the scattering rate increases with the square of that number, so it will be increases.